oxidation is loss of electrons, and reduction is gain of electrons. Okay. When a species loses electrons, it is oxidized. When it gains electrons, it is reduced. And we have a very good example here for the ferric zinc metal system. So when we combine these two electrodes or half cells or half reactions, the zinc will be oxidized. It will lose 2 electrons and be converted into zinc ions, Zn plus 2, so this is oxidation. The ferric will gain an electron and will be reduced to ferrous, Fe2, and this is reduction. Okay, as simple as that. And في يعني أسئلة just revolving about this point، يعني بتدور في حول النقطة هذه بتاعت oxidation reduction. And which is oxidizing agent, which is reducing agent. Okay, and then we'll have an MCQ with the balanced and unbalanced equations. You have, of course, to choose the equation, the balance equation. We're going to balance in as far as the number of atoms and the number of charges on both sides of the reaction. They must be balanced, okay? And you have 4 multiple choices. 3 of them are wrong. They are not balanced. Only one is balanced, and I think it will be very easy for you to pick up the balanced equation. That's quite easy, and this is repeated, by the way, for 2 more questions. Like for carbon, the reaction of oxygen with iron. Oxygen, of course, oxidizes iron not, metallic iron to ferrous ions. And here oxygen, of course, is the oxidizing agent. Iron is the reducing agent, because iron will be oxidized to ferrous 2 plus, and oxygen will be reduced to water. Again, you will have 4 equations, and you should be able to pick up the correct balance equation. And also oxygen, carbon monoxide and ferrous ions. This is in preparation of metallic iron. You know that we react carbon monoxide with ferrous ions with the ore. The oxide of iron is known as ore, ferrous oxide. And we need the metal, the pure metal iron, so we reacted with carbon monoxide. The ferrous ions will oxidize carbon monoxide to carbon dioxide, and they will be reduced to the ferrous ions, that is, will be reduced to iron, metallic iron. Okay, so again, we should know how to pick up the correct balance equation for this reaction. So as I told you, it's rotating or revolving around. Oxidation is loss of electrons, reduction is gain of electrons. Then you will have a mathematical calculation. I told you before about it, where you will be asked to find the equilibrium constant. You will have the 2 reduction potentials, the E nodes of the 2 half reactions or 2 half cells or 2 electrodes making the cell. For example, ferrous and zinc ions. We call each one of these either half reaction, half cell, or electrode. So if you combine them, we'll make a cell, or a complete cell, or a complete reaction. And electrons, of course, will flow. And we can calculate the equilibrium constant of this reaction from an equation. And you know that equation is a cell reaction, or cell potential times number of electrons divided by 0.0592. Okay. So you find a log KAQ. This equation will give you a log KAQ. And then you have to find the anti-log to find KAQ. You will have 4 choices, okay, of KAQs. One of them is correct, the other 3 are not correct. So of course you have to choose the correct KAQ. Okay. I hope you will get that right also. So this is as far as oxidation reduction is concerned. Try and fish with true and false questions, which are very easy. True and false questions, also based again on gain and loss of electrons. برضه في definition تانية طبعا للاكسيديشن reduction. Oxidation is gain of oxygen and loss of hydrogen, صح؟ Or reduction is gain of hydrogen and loss of oxygen, and you know all this. Okay, but most we use electrons. Then we will move to, I think, these are the most, the major points or the most important points about oxidation reduction. And then metal ion complexation. You know that metal ions can be complexed by ligands. And ligands are made of metal ions. They are deficient in electrons. We call them also Lewis acids or electrophiles. They need electrons because they are deficient in the منخفض الإلكترونات. So they can find these electrons in nucleophiles. We have nucleophiles which donate electrons to the metal ions. Nucleophiles donate electrons to the metal ions, the electrophiles. And there are certain atoms which when found in a molecule, will act as nucleophilic atoms. And these are nitrogen, oxygen, nitrogen, and sulfur. So these three atoms are electronegative atoms, and they have an excess electrons that they can donate. Not donate fully, no, because the bond that will be formed between the this nucleophilic atom and the metal ion is not a covalent, it's not ionic. No, it is coordination bond. Coordination bond. Okay, the electrons will be donated by the nucleophile. Okay, nitrogen, oxygen, or sulfur in the ligand molecule. Okay, and usually there are more than one ligand in one complex. And we find more than, for example, magnesium will bind with magnesium ions, always ions that form complexes, not the metals themselves, no, the ions. Magnesium combined with ammonia, four atoms of ammonia, not just one atom. One atom, no, to make a ligand, not just one molecule, sorry. So usually a complex is formed by the metal ion complexes more than one ligand molecule, up to 6 sometimes. We have seen this with potassium ferrocyanide and potassium ferrocyanide. You have them in your nose. And this, of course, will be the number of ligands around the metal ion will be the coordination number. Coordination number, we call it. And the charge on the complex will be the charge. It depends. If the ligand is neutral, the charge will be that of the metal ion. If the ligand is negatively charged, well, the ligand can be either neutral or negatively charged. Then we'll have to calculate, if it's negatively charged, we'll have to calculate to subtract the number of ligands, the charges on the ligands from, or to add it to the metal ion. Suppose we have 4 ammonia complexing molecules complexing with magnesium ions, 2 plus, but ammonia is neutral, has no charge. So the charge on the metal complex will be +2, that of magnesium. But if hydroxide ions complex with magnesium, hydroxide, of course, also 4 hydroxide ions complex with magnesium, hydroxide ions carry negative charge. So we have 4 negative charge plus 2 positive of magnesium. So the charge will be here -2. The charge on the complex will be -2. Because -4 plus 2 is equal to -2, and so on. You'll also be asked to find the coordination number and the charge of the complex, of a complex. Sorry, in oxidation reduction, if you want to find the cell potential, because some metals have reduction potential بالminus, others have positive. For example, ferric ferrous has a positive of 0.76, while zinc is minus 0.76. So when you want to find the cell potential, you have, of course, to subtract the lower from the higher. It will be 0.77 for the ferric ferrous minus 0.76. So it will be 0.77 plus 0.76, which is 1.53 volts. Take care of this, please. Right. Now to the organic chemistry. I think the organic chemistry, I have 15 minutes to talk about organic chemistry. I will try to show you the PowerPoint. Right. Can you see the PowerPoint? Hello.
Yes.
Okay, good. Now, when it's on organic chemistry, very short course plan. The organic chemistry is the chemistry of carbon compounds, okay, of carbon compounds, because carbon is the most abundant element in the in organic compounds. It's followed by hydrogen, oxygen, and nitrogen in this order. Okay, so the abundance توفر الاتومز abundance ما تتوفر الاتومز في الorganic compounds is carbon, hydrogen, oxygen, and nitrogen in this order. Any other order is not correct, so please take note of this. Okay, fine. And when the carbon, for carbon to form in hydrocarbons, we'll talk only about hydrocarbons as we did in the ashes. Carbon, of course, has the ability to form alkanes, alkenes, and alkynes by hybridizing its orbitals in three ways. sp3 hybrid orbital to make alkanes, sp2 to make alkenes, and sp to make alkynes. So you should know this also, right? What orbitals carbon uses to make the different types of aliphatic hydrocarbons, aliphatic هم الالكينز والالكينز والالكاينز. I will not ask you about nomenclature, no. Right. قلنا alkanes are very reactive In alkanes, the reactive bond is the carbon-hydrogen only. Carbon-carbon is unreactive. The sigma bond, carbon-carbon in alkanes is unreactive. But the sigma bond, carbon-hydrogen اللي هو sp3 1s طبعا صح؟ sp3 1s. This bond in alkanes, the carbon-hydrogen bond, is reactive, and the hydrogen can be replaced by halogen. Okay, a halogen such as chlorine or fluoro group. Carbon-hydrogen bond in alkanes, we call it the reactive bond. Okay, so if we react an alkane with, like here, ethane with chlorine, we'll get ethyl chloride by free radical substitution. Those free radicals will be formed. I explained this to you. There is no time to go through it again, but free radicals will be formed, and the reaction is free radical substitution. Why substitution? Because a hydrogen in ethane has been replaced or substituted by a chloro group, صح? And a hydrogen chloride molecule has left reaction, صح? Substitution, then عندنا addition. So alkanes undergo substitution reactions, okay, through free radical formation with halogens. But a very important point is that we must use heat or light to generate the free radicals. Light, UV light, ultraviolet light to generate the free radicals necessary for the occurrence of the reaction. Right. And then we talked about, in alkenes, where we have an sp2 bond and and 2p bonds. The double bond in alkenes is made of two bonds like here or wherever. One of the bonds is 2p from 2p orbitals shared, and the other bond is sigma. So this 2p is known as pi bond, and the other one is sigma from the hybridized sigma orbital. sp2 is a sigma bond. Okay, and in alkenes, the reactive bond is the 2p. It's of high energy, so it reacts first. Whenever we add a reagent, it will react first. And here are the reactions of alkenes with some reagents. Like if we react an alkene with hydrogen halide. Halide here can be bromine, chlorine, or iodine. Okay, so it will add, the hydrogen halide will add, nothing will leave the molecules. Okay, the H, the hydrogen will add, and the X, the halide, also will add. So this addition. Alkenes undergo addition reactions, no substitution. You have to take care of this point. Okay, alkanes undergo substitution reactions. Alkenes undergo addition reactions. Then again, alkenes plus water will add, or hydrogen with hydroxyl. This hydration, the first reaction is on hydrohalogenation. Hydro from hydrogen, halogenation from halogen. Second reaction is hydration, addition of water. Then we can have two atoms of halogen molecule adding XX, as you can see here. And this is halogenation reaction. And we have here hydrogen adding to the alkene to give alkane. Propene gives propane. And this reaction has two names. It can be named as hydrogenation or reduction. Okay? It's also reduction. Addition of hydrogen is reduction. Okay, so be careful about this. This reaction بالتحديد, addition of hydrogen is either hydrogenation من hydrogen addition, and reduction from that hydrogen will cause reduction. When this reaction, of course, takes place only in the presence of platinum, not like this. You have to add platinum as a catalyst to lower the activation energy of the reaction. Please, if you haven't added yet, add it now. This reaction takes place in the presence of platinum. Now, here is formation of 1 and 2 chloropropanes. We talked about the mechanism of this. It's free radical again, sorry. It's here by carbocation formation. From alkenes, hydrogen chloride gas will add to an alkene such as propene through carbocation formation. We give 1 chloro and 2 chloropropanes. The 2 chloropropane will be the major product because the secondary carbocation is the stable, more stable than the primary. And also, these two products, 1 chloropropane and 2 chloropropane, can be formed by the reaction of propane with chlorine. Okay, yes, through free radical reaction. So if we have propane and CH3, I think I will try to just very quickly do it here. So this is very important notation. I want to make a so CH3 CH to CH3. So this is propane. Okay. So propane can react with chlorine through free radical formation, which will form on this carbon or on this carbon. If it forms the free radical on this carbon, it will give 1 chloropropane, and if it forms on this carbon, it will give 2 chloropropane. So same as in propene, but propene, the agent in propene is hydrogen chloride. You have to be careful about this. If we use propene, we have to add hydrogen chloride gas. If we use propane, we have to add chlorine gas in presence of light, UV light, or high temperature. So both reactions will give 1 chloropropane and plus 2 chloropropane. In both cases, the 2 chloropropane will be of higher concentration than 1 chloropropane because the 2 chloropropane, the secondary free radical or secondary carbocation will be more stable than the one primary or secondary free carbocation or free radicals. Okay. And also we said, of course, 2 chloropropane, we want to separate the two, the mixture into its components and separate the two components of the mixture. We use fractional distillation, make use of the difference in boiling point of the two compounds. 2 chloropropane will have a lower melting point than 1 chloropropane. Well, it is smaller in size, it is branch, smaller in size, it will evaporate first. So we use fractional distillation. So 2 chloropropane will come first, will distill first, يعني يقطر التقطير به أول. Okay. So now out of this and this reaction, okay? You are going to see this reaction also in the exam. Formation of polymers, okay, from alkenes. Very quickly, we must have an initiator بادئة يعني تبدأ أو مبتدئة للتفاعل كويس اللي هي X. الأسيسك هذه النجمة هذه أسيسك يعني free radical. Okay, يعني free radical. So this initiator free radical قلنا peroxide will attack the pi bond again of the alkene اللي هو هنا ethene أو ethylene لأن هذه polyethylene ester. Okay, it's known as polyethylene ester. And ethene, hold on, Ayubic name is ethene. But in the ester formation, sorry, the polymer formation, we use ethylene, the name ethylene. It's all right, polyethylene. So the initiator free radical will add to the pi bond of ethylene to give a new free radical of ethylene like this. Now this new free radical of ethylene will add to another molecule of ethylene again. And a new radical will be generated, and so on and so on and so on for millions of times till a polymer is formed. And of course, it can be used for different purposes. Okay, polyethylene ester. So it's a free radical addition reaction. Yes, the polymer formation. So you will see this structure. inshallah في الامتحان, and there are about 5 statements. Some of them are correct, some of them are wrong. I think there's just one wrong statement. 4 will be correct. Number 5 will be wrong. So you'll have to choose the wrong statement, of course. And most importantly, the polymer formation occurs only at high temperature and high pressure. This is very important to know that. Not just add the initiator, the periodical initiator, or and an ethene and leave it to go. No, it will not go. The reaction will not go unless you use high temperature and high pressure. Okay, and the polymer will be formed. Then I think you'll have to know about some of the uses of polymers, especially those related to engineering. Those that are not, okay, you will have a question on that also. Okay, so this is it. It's all what the exam is about. Anything that I have not mentioned is not included. Okay, are you with me? Hello? Okay. Anything that I have not mentioned will not be included. Okay. And again, I'll try, by the way, I'm supposed to record some. ليش في صدى في الصوت؟ I'm supposed to record some lectures, inshallah, and by Thursday or Monday you will find them on the system. Okay. يلا السلام عليكم.